All right, my friends, let's get started. So if you were starting from scratch with this problem, step one is the same as step one was before, where you just factor the denominator down as far as you can, as long as you're still using integers. Once you have it factored down, it would be a matter of noticing that you have what's called a repeated linear factors case, and that would just affect your form. So the form in this case would be a constant over the first factor, but then so that your least common denominator is the denominator you started out with, you'd have a constant over that factor squared. So hopefully that part makes sense. Then, just like before, you switch gears and you start adding the fractions together, trying to get least common denominator, and most importantly, trying to get the denominator you started out with. So I hope it makes sense. You'd take a over x plus 2, and you would only need to multiply that by x plus 2 over itself. And then what would you have to multiply b over x plus 2 quantity squared by? Well, the answer is nothing, or 1, I guess. But it's fine. It already has, the denominator you're trying to get it to have. Okay, so now let's go ahead and follow your simplification nose. So we'd have ax plus 2a plus the b over there, and it would be all over x plus 2 squared. There we go. So I'm going to go ahead and bring this fraction over here down to remind myself what I was trying to get to happen in the first place. So denominator battle, 1. And now we just have to focus on making the numerators equal each other. So I'm going to set x plus 1 equal to, and I'm going to organize this numerator over here as ax, and then I'm just going to group the constant terms, as in things that don't have x's in them, in parentheses. So if I need the polynomial on the left to be the same as the polynomial on the right, then I would need the number of x's to match, which means a must be 1, and I would need the constant value to match as well. So that means that I would need 2a plus b to equal 1. Okay, well, since I already know a is 1, if I substitute that into row 2, I would have 2 times 1 plus b equals 1, and then subtract the 2 over, and you'd have b is equal to -1, like so. Okay, well, the whole point was to decompose the fractions, so don't forget to take your a and your b values and back substitute them in your form to make a conclusion. So the conclusion would be that if you have x plus 1 over x squared plus 4x plus 4, it could have come from adding the following fractions together. 1 over x plus 2 plus, or minus, I guess, 1 over x plus 2 quantity squared. There we go, my friends. Okay, I hope that makes sense. Let's move on to the next example. So I'm hoping at this point you realize that the procedure does not change from what we did in the distinct linear factors case in part, in the last part. Really, the only thing that changes is the forms for certain special cases. So between now and the next video, I think go ahead and just copy example 2, which is where we're just going to talk about how do you do the form part. So notice I'm not asking you to actually decompose each fraction. I'm just asking you to write the form. Okay. So in each case, I've given you different situations you could be in. See if you can figure out what some of the forms would be. I know some of them we haven't talked yet about what the forms would be, but do what you can, and then I'll go through it with you in the next video.